War isn't murder, they don't ship out the poor, and the bullets they fire aren't part of the cure. War isn't murder, land is a right, but the bank's called dibs, it's something you can't fight. Let's talk about dead people, dead people.
So let's talk about a dead people. Dead people. So anyway, looking at this other problem that I was going through here, it says, no, that's not the one. It was about a book. Is it possible? Heartbeats. Oh, that's the one. The dying worldwide, right there. 10 to the 9th people dying worldwide. Is that possible? It says, is that possible? Big question. Is that possible? So let's take it from the top here. We'll start something pointing out that the average worldwide death rate is, so we're going to say 6K per hour, or 6,000 deaths per hour. All right. We should note that estimate is based on 2025 death rates, where we had 63.14 million deaths in 2025. And here we go. So let's just say the question says 10 to the 9th. Let's evaluate what 10 to the 9th is. That's going to be a 10 times a 10 times a 10 times a 10. That's 4 tens. It's 5 tens, 6 tens, 7 tens, 8 tens, and 9 tens. That's 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, or 9er. 1 million. Well, that's a billion. That's a billion. 1 billion deaths per year. And so we have to ask ourselves, is that possible? So if that's 1 billion deaths per year, and then we know that the population, that's a good point to make here, the population of the world, and what we're going to use is 8.3 a billion. So 1 over 8.3 a billion. The 10th and 9th cancel. And let's turn it into a percent. And what it comes out to be is 1 over 8.3 times 100. And we get about, let's approximate this. It comes out to be a slightly different number, but it's approximated to be about 12% per hour. That's 12% of the world's population per hour. Wow. Is that possible? Well, what we're really talking about here is 12 out of 100, representing a percentage as a fraction. That will reduce down to 6 over 50. Divide both numerator and denominator by 2 again. We get 3 over 25, which is a 0.12. That's our ratio right there, which is very close to 1/8, which is 0.125. So what we got here is a linear equation where y equals, one thing we know is our y-intercept would be 8.3 billion people in the world currently, and then we would be subtracting 1/8 of that per hour So 1.3 per hour, let X be the hours. Hours, or I guess we're saying more hours assigned as X. So let's hold on to that little nugget right there we have, and let's bring up the wonderful Desmos calculator. Alright, so notice I put in my formula. Notice I just used the y-intercept over there, and it would work out just fine if I did. Just put the y-intercept right here, and then we still have this. Notice our y-intercept at our current state. Let's say that we are at year 0, time 0. Right here, right now, we're at 8.3 billion. So imagine this scenario. Every hour, the population going down. Come on, trace it. There we go. The population going down. And within 8 hours, we have negative human beings on the earth. So then I said, hey, AI, what about nuclear war? Is it possible? But this crazy, so here it's saying the same numbers I had. The current world population is 8.3. Come on, don't turn off on me. And in 1/8 loss per hour, matching 10 to 9 people in the question we were talking about. But for comparison, that's still 6,000 factorial to 17,000 factorial. Let's calculate that real quick. Okay, I'll go back to that here. Let me just redo it, and I'll show you how I was able to get the calculator. So 6,000 factorial. Notice it gives me an undefined. So let's just break that apart as 6 factorial. Well, I don't know if this is exactly true. Hold on. So that's what they were getting me, is like the 6 factorial. And then I thought, okay, well, let's just do 6 factorial times 6. But that's not the same thing. This is undefined. 6,000 factorial is undefined because this is what it is right here. Factorial here. That's what 6,000 factorial is, which is huge. Look at that power on the exponent. That's huge. So, the question asks us, right? What it says, if it's clearly impossible, it does not make sense. And looking back, hold on a second here. And I asked the AI for some clarity, as you can see right here. I was confused because of the way it worded before. And then the AI says it was a typo mistake, not a mathematical claim, that 6,000 factorial is smaller than 10 to the 9th. So here we go with the normal global death. 63 million people die per year. That is roughly 7,000 deaths, so there we are. So the actual death, and then we go on down here, and this is where I was looking. See, 6,000 is astronomically huge number. Astronomically huge number. Oh, I wish it would zoom. Far, far larger than 10 to the 9. So that all being said, it's not clearly impossible. It's not clearly impossible in the next hour that 10 to the 9 people will die worldwide. Despite the fact of what AI had responded to the question right here. Notice it says, no, it does not make sense, but hey, let's consider total and complete nuclear war, and it's perfectly plausible. Let's talk about a dead people. I mean a dead people. Okay, so I was like, hey, I'll make some more calculations, but I was starting to get lazy. So I'm like, okay, if we're getting 6,000 factorial deaths per hour, I was like, okay, so how many deaths is that per second? So here we go. We take the number of 6 factorial right here, the huge number, and it comes out to be approximately 7.9 times 10 to the 3,555. So that is 7.9 followed by that many zeros, death every second. An unimaginably larger number than the entire population of the universe. So physically meaningless, even as a nuclear war scenario. But I still say it's possible. It's still possible. So I decided, okay, let me look at this. This was an estimate that I was able to get about if it was simply based upon 100 kiloton nuclear warheads, and we had 4,000 of them simply between the United States and Russia. So what I wanted to do was question the AI. Basically, okay, that was based upon U.S. versus Russia with that size weapons, 4,000 of them, and I also threw in, okay, what about the other nuclear powers of the world? What would we end up? What estimate could it come up to get here? So I thought, oh, it probably should be larger now. But anyway, here's what it comes up with. It says, as we can see right here, a 360 million quick death scenario from a large U.S.-Russian war is already an extreme but still partial exchange estimate. And scaling it to a true global all-arsenal war pushes you toward billions of deaths, not just a linear bump. So we're talking about 360 million here. And then let's just go over, and we're talking about all the warheads. I can share this as well. But the big thing we want to go in is going down to the big picture here. So the immediate would be a few hundred million, which is greater than the population of the United States. And then within a couple years, those deaths would continue to be up to 5 to 6 billion. Remember, we only got 8 billion people. We only got 8 billion people. So 5 to 6 billion, we now only have about 1 or 2 billion people left. And again, that's using the 360 million as a starting point. Total and complete global war estimate is still not 10 to the 9th deaths per hour, but rather several hundred million killed very quickly, and several billion more dying over the following months and years, folks. Let's talk about the dead people, y'all.